In this video, we're going to talk about the titrations of polyprotic acids. Before we start with polyprotic acids, let's review a monoprotic acid titration. So let's say we have a 0.02 mole sample of some acid, which I'll call HAC, and I want to titrate this with 1 molar sodium hydroxide. So the titration equation is HAC plus hydroxide to make water and conjugate base. If I were to draw the titration curve for this, so pH versus volume of hydroxide that's added, we're going to be looking for a couple of things. First things first, we're going to be looking for an equivalence point. So an equivalence point is found when one equivalent of hydroxide is added to one equivalent of acid. And so let's find out how many moles of acid we have, and we'll go from there. So since we have 0.02 moles of acid, and we know that it's a 1-to-1 molar ratio, we're going to need 1 mole of hydroxide for each 1 mole of that acid, which means we're going to need 0.02 moles of acid, of hydroxide, which 1 liter for every 1 mole gets us 20 milliliters of hydroxide. So let's say 20 milliliters is around here, 40 is over there. We will be completely titrated at 20 milliliters. Now if this were a strong acid, this would look something like this. And if it's a weak acid, as we've discussed in the past, we're looking for a titration curve that looks something like that. These two really should be overlapping up here. And this is the equivalence point, or the point at which we've added 1 mole of hydroxide for every mole of acid that we started with. Notice for the strong acid, that's going to happen at the pH of pure water, which at 25 Celsius is 7, because what we have present here is we have a conjugate base which is not basic, and water. On the other hand, when it comes to the weak acid, we're going to have a pH that's higher than 7, and that's because our conjugate base is going to be slightly basic. The question now is polyprotic acids. Unlike a monoprotic acid, a polyprotic acid has 2 acidic protons. So let's use the example of sulfuric acid. And once we've titrated fully one of the protons, we're left with something interesting. We're left with something that is both an acid and a base. So hydrogen sulfate ion is the conjugate base of sulfuric acid, but it itself is also still an acid. And so hydrogen sulfate can further be titrated with hydroxide to make the sulfate ion and water. So we see here that for a diprotic acid, we will need 2 molar equivalents of hydroxide for every 1 mole of sulfuric acid. Similarly, if we look at the titration curve, we expect to see 2 equivalence points. Equivalence point number 1 and equivalence point number 2 for the 2 protons. What you'll notice, though, is that these 2 equivalence points happen at exactly the same volumes. So let's go back to our original example. Let's say we have 0.02 moles of sulfuric acid. We're going to need 0.02 moles of hydroxide just to get to equivalence point number 1. And we're going to need another 0.02 moles of hydroxide to get to equivalence point number 2. And that means that you're going to need, in the case of 1 molar sodium hydroxide, 20 milliliters to get to the first equivalence point and 40 milliliters to get to the second equivalence point.